or for sort of sub list, I guess, of cells. And
so like pool, yeah, okay.
okay.
Right. So this is, I don't know what that molecule.
Yeah, this is the PBMC data set.
Okay.
So here's some B cell markers, and there's a couple of different things we can do to get at subsets of cells. And I can send you links to tutorials that go through this. This is just going to be like a real quick crash course that you guys have a meeting here in half an hour. But we can select a group of cells here. So I just use the lasso tool.
Lasso, right? Okay.
On the left. So this is by eye, right? So it's somewhat subjective. I'm not using. I could also use fold change cutoffs and things maybe a little more mathematical. But I'm using the lasso tool by eye here.
Is this a subset that is a particular? Is this a gene or a subset? Like cluster? I guess it's a cluster. Let's say it's pretty positive for some gene, though.
Right. Well, so as clustering. Keep in mind, the clustering is driven by all of the genes being expressed.
All right. Yeah.
So the cluster is already.
We have a little thing that's covering up. Can you move the mouse? Because see, we're covered. But this right-hand side is covered up by our little. Can you move that? Try to grab the top. No, just grab the top of it. Yeah. No. Just yeah. There you go. So we can see it. Great. Okay. So we can see the cluster. Right. Stick it down there. Okay. We're with you again. We just couldn't see the right-hand, cluster bar.
Right, okay. So you can see the list of the different.
Right.
Okay. Yeah. So this data set is clustered purely on whatever's being expressed. So right now looking at this, I have no idea what any of this data or what types of cells these are, what types of cells these are. It's only when I go in and look for particular markers.
Oh, I see. CD79. That's what I was thinking.
Yeah,
so this is.
So I got CD79 alpha data.
Okay.
And saying okay. And so now I have more confidence to just somewhat subjectively here, isolate these cells and say that these are B cells.
And do you have both? Is that CD79? Just a question, because I can only do one at a time. Is that 79A and B?
You could. So why don't I drop one? So here's.
Oh, I see.
Just an alpha.
I see. No, I know. If you put two there, then it does both. Is that right?
Yeah.
Because what we do, we put one there and we have to touch it and highlight it. So now you're saying maybe we don't have the latest version. So you can put as many genes as you want over there and it'll highlight whatever okay. Right?
Well, the real problem for us is that these are PBMC, so the different cell type are very, very different distinctive gene markers. But we want to zoom into within B cell, and of course when we do the t-SNE, let's say we're interested in IL-4 receptor, we don't see it clearly form because of the IL-4 receptor.
Right, it's dotted
that
around.
That doesn't form a cluster at
But
all.
can you let him do this part, and then we'll go to that,
Right.
So go ahead with what you're doing here. Oh, I see. Well, okay, I have.
Receptor.
Yeah.
I have.
In this data set, and I don't know if this looks like yours as well. Yeah, it does not look like there's significant IL-4 expression.
Receptor.
You put the
IL-4 receptor.
IL-4R.
Yeah.
That's it.
Right,
That's it.
Right.
Yeah, there they are.
Right.
Just a few, but.
Yeah. So in this case, I'm seeing some in this population here, and then through this population.
Right.
So how could we pull? I don't know how many there are, but I think it's a number somewhere there. How could we pull those out and analyze them?
Right.
Yep. So you can use whatever method you want to identify. So we use the IL-4 and said, okay, we're interested in doing this cluster and this cluster.
Mm-hmm.
And so that's where the lasso tool comes into play now, and I can just lasso around it. I mean, this is the way I think it's easiest. And now I've sort of identified these two clusters, and I give the category kind of whatever name
Right.
I want. this is arbitrary, whatever.
Yeah, right.
And so now what I'm left with is I can see I've got 2,816 cells out of, I think this data set has 8,000 in it.
Okay.
That I've specifically lassoed. But what I can go a step further and I can, subdivide this and say, this is IL for R2 because, these are clearly, there's something different between these two populations, right? They're clustering quite distinctly, even though they both have ILR4.
Right, okay.
IL4. And so I can stop right here. If I do export cell type,
Right.
exclude unlabeled. Exclude unlabeled says what that means is ignore all this gray stuff, right? We've purposely lassoed these two, this blue and this orange. That's all I want to look at right now.
Uh-huh.
So that's what exclude unlabeled means. So I can save this as a is it a text file or CSV? Let's see here. Looks like it's just a CSV file. So now what I have is I have a list of the barcodes. So I have a list of those actual cells.
Oh, I see.
And whether I've assigned them to, whichever group. Okay, so now this gives you that refined list. Now you are going to have to use some other tool probably to dig deeper into those. Because this would be pulling out of the gene barcode matrix, right? That master table you have of 8,000 cell barcodes and however many genes. But this does allow you to kind of quickly develop a list of cells of interest.
Mm-hmm.
The other thing we could do here is look at what's significantly differentially expressed between those two. So if I hit the significant genes button, do locally distinguishing. Now it's essentially doing kind of a pairwise analysis between these two clusters. How long it runs depends on how many cells we have, but so now we can see the top genes that are being, overexpressed in the this one, the orange set relative to the blue set, and then vice versa. We can see the ones that are overexpressed in the blue set relative to the orange set. So we can start to see what's different specifically between these two clusters. And again, we're kind of ignoring.
Yeah. Can you export that list?
Yeah. So from reports as a heat map, which is like it's kind of okay, but yeah, probably you want this G table, which is just the tabular form, and we can export that as well. Sorry, I think it's this button here. And that looks like. Yeah, there we go. So now we have, the gene name and its, relative expression in those two different populations I've identified, and then the p-values. So yeah, you can export that as well.
So you could then make a heat map out of this, right? I mean, a heat map that you could work with, because the heat map at the bottom, I know there's one here already, but it's hard to work with that one. You can, what I mean? You can't really specifically look at it very easily gene by gene. Your heat map down here, I can see we want to know like the top 100 and bottom 100, the difference. And so once you export it, then you can put it into, say, CustViz or some other heat map program. Or you can do a heat.
Yeah.
All right. Can you do something like pull out, this is a little tougher question, I think, pull out the IL-4 receptor expressing cells and look at their barcodes?
Yeah, so that's, okay, so if we go back to gene expression. So we did that,
you use the loop, the
lasso, right? So
the lasso.
That's somewhat subjective. We could also we could set this criteria here, show me, you can set it by linear or log scale, based on the expression of those genes. And let's see. Yeah, so then when we hit this filter button here,
the filter button.
Yeah, I can assign it to that. I have to probably make a different group here, so we'll just call this, I don't know, expression type. Again, these are completely arbitrary how you choose to do that. Okay, so now I have 153, which I can change the color. Right now the lit up is blue, but maybe it's easier if I change it to green here. I don't know if that's any easier to see, but they're kind of mostly in these two populations, but there are some other ones in these other clusters, these other expected cell types.
Or I guess you could even do a lasso tool and maybe get that cluster and then do this within that cluster, right? In other words, we're interested in the upper right cluster, IL4R up in...
Only in B cell, but IL4 receptor positive.
The IL4 receptor positive in that one cluster up there.
Yeah, it's a good question. So we've got it, we've got it right now currently. I don't think you could do that.
Adam, try to use a split view. That might help. Split view.
Split
view. Oh yeah. So when you do split view, what you're doing is sort of like almost like a karyotype.
Yeah, right.
Laying things out. Yeah, thanks, Evan. That's perfect. So yeah, so if I do split view,
and then you can get again.
Yep, and then we can lasso. We know this is kind of. Yeah, there you go. Yeah, perfect. Thanks, Evan. Right.
Oh,
so that's, IL4 cluster.
Cluster 1 or something.
Yeah. Another name. And so I can put this back in, and so now, the ones you cared about, you can see how it's.
Now the 43. Okay, that's good. And then, and make him say, And then what do you?
Yeah, we can export all that, right? So we can go export, and then we get the barcodes of all these red ones, and then also all the green ones.
Can you make if you export them, can you do something like, I'm thinking of a heat map or something, some way to export the genes, because there's genes underlying those red dots. How is there an easy way to export, like you did with the heat map down below? Is there a way to, look at the top IL4 genes in that cluster versus the ones that are negative, group on the IL4 positive cluster, and then show it down below, those cells, right?
Just click the IL4 cluster.
I mean, we can look at the differentially expressed genes between these two, right? So the ones we've identified in red and the ones in green, we can do that. But that's just looking at the top differentially expressed. To get all the genes from these red ones, you would go into the master gene barcode matrix.
But there it is right there. You've got a heat map, and then you could export that, right?
Yeah, but again, right now, this heat map here, or the table, the tabular view, is just looking at what is top differentially expressed between the red and the green here.
Well, it's something.
Within any given red one, there's hundreds of other genes being expressed as well.
Right, but you could export that. The high and the low, what you just did, the barcode, or not the barcode.
Yeah.
Those, though, you could export those.
Right here.
And then you could look at all the other genes, get a list larger. I guess the list is there too, but.
I think this is the right one here. Yeah, so in this case, we're getting, this one's like right now sorting with ones that are underexpressed in that little cluster that, whatever color that was.
I think that's an advance.
In a red.
Yeah, we can do this. The problem is that these are receptor.
Oh, okay. Now we can do this, but it's good to know how to do it. But then the next thing is if you can go to the B cell receptor, the VDJ. What can we do with that we're not, we just get, well, anyway, maybe, how would we look into VDJ? Oh, yeah, there you go. What we'd like to do is do like clonality or a tree or a circus plot or things like that.
So it definitely is much more limited. I mean, you can look at. Let's see if I get a second sample.
I guess T cells are okay too.
Let me. I'm just downloading a second sample real quick.